Hi Nate, it's Aunt Sissy. I'm trying take two of a quick video for you on GeoGebra. My first one had no sound to it. So anyway, I'm going to send you this link. It's just geogebra.org/download. And here's where you can download the actual program. We've got it for tablets, desktops, and phones. The most complete one is the one for desktop, so I'd suggest starting there, but you can download it for your iPad if you wanted. And your phone just has some limited capabilities there. And I'm not sure what they are anymore. I know it's improved a lot, but I tend to use it on my laptop, so I'm not sure. So once you download it and you open it up, it's going to look like this. In just a moment, when it opens up, it looks like this. So I'm going to make it bigger so we can kind of talk through here what you've got. So we've got different views here you can look at. This is called the algebra view. This is the graphics view. I can add on other views, such as a spreadsheet view. So there's a spreadsheet I could use if I wanted to. I could add on a second graphics view if I wanted to, so it would just give me another one of these down here. 3D graphics and CAS, which is a computer algebra system, which I'll show you how to use in a little bit if you want. So in each one of these views, when you're down here, when your cursor is in that particular view, the tools that go with the view are right there. So in a graphics view, here are all of the things that you can construct. We've got different kinds of points, points on an object, attaching points, intersecting points, midpoints, things related to lines and line segments, perpendicular, parallel, tangents, etc., polygons, circles, and so forth. Here's angles. Here are all of your transformations, and anything wanting to do with the actual graphics view itself is on this last one. So the important thing to remember about these is you'll just have to play and get used to what is where. But whenever you select something, the last thing you selected in this list is going to be the picture that shows there. So that picture is not always going to be the same. And once you've selected something, when you're done doing it, go back and hit the cursor here, so you'll no longer continue to create whatever it is you were creating. So if you want to get rid of any one of these views, you just hit the X in the box up there and it's gone. So here's what we basically work with most of the time are an algebra view and a graphics view. So for example, if I want to graph the equation y equals 2x minus 5, I just, in my input bar down there, enter it. The symbolic view shows up here in algebra, and then it graphed it automatically over here for me. So this particular program, everything you do is linked. So if I do something in algebra, it's going to show up in graphics. If I do it in graphics, it's going to show up in algebra. If I do it in a spreadsheet, it's also going to show up in the other places as well. So everything is linked together. And by linked, that means if I change one of them, it changes everything else. So I can just grab and move this line, and notice it changed that equation over there too. Now, as I'm moving it, I'm not changing the slope, so the slope is not staying the same, but the y-intercept is changing. I believe if I grab it towards the ends, and now I'd have to create this differently to be able to change the slope, but that could be done. So, for example, if I, say, do a line selecting 2 points, point here and a point here, I create the line by the 2 points. This is the second object here. Notice when I select this, this is darkened too, so I can see which is which. And it's labeled that says B down here. It says B up there. So that is the equation for this particular line. If I, oops, again, that's why you hit. Oh, shoot. Edit, undo. There we go. Edit, undo. That's not what I wanted to undo. I want to undo the other thing. Anyway, let me try this again. 2 points. There we go. There's my line again. Go back there, now I can drag things. So if I change this point B anywhere you want to change it, notice that the coordinates for point B changed and also the equation for that line changed because I'm changing both the slope and y-intercept. And you'll see that that particular equation was entered in standard form instead of slope-intercept. That's what it automatically does. You can change its form right here by changing the equation to y equals mx plus b, and it puts it in slope-intercept form for you. Or you can change it back to standard form. So just a little bit there about how the linking works. If you don't want to see something, just the little circles next to it is what makes it show up, and you can just hide it that way, or if you want to, you can delete it if it's selected. All right, so some cool things you can do here. First of all, I'm going to work in this coordinate plane mode real quick and show you a couple things. Then I'm going to switch over to geometry because I know you're doing geometry right now. But one of my favorite things to do with students is when we're thinking about different kinds of functions is to create sliders. So I'm going to create a few different sliders. This one is A. I'm going to take it, go from -10 to 10. As soon as I'm done creating these, I'll tell you what they mean. I'm going to do another one. Call this one H. -10 to 10. And then do one more. I'm going to call this one K. And go -10 to 10. So, and then choose my select again. So essentially these are number lines that have a point that moves along them and has a value anywhere from -10 to 10. Notice as I move this, it changes the value of A over here. H, same thing. K, same thing. So we can use these to build things with. So for example, when you were studying quadratics, you probably learned the excuse me, the vertex form of a quadratic equation. So that's A times X minus H to the second plus K. Oh, I used a capital K on that one, so I have to make sure matches here. And there's my equation. Now notice up here, A, H, and K are no longer here. It's using the values of these sliders, and as I change the sliders, the graph and the function change. So as you know, A impacts how skinny or fat it is, if it's concave up or concave down. Our H and our K determine where this vertex is of that parabola. So parameters are a really nice way to be able to explore all your different function families, and hopefully you've done some activities like that at school. All right, I'm going to close that now. Let me delete this stuff. Delete, delete, delete. I'm going to add on the graphics view again. Sorry about that. I'm going to go over here and select, this is how I change anything with the graphics view, and I'm going to turn off the axes. And now it just looks like a regular plane. And here I can create anything I want to. So I can create a regular polygon. I want my regular polygon maybe have 6 sides. There it is. It automatically gives the points that I chose, it gives me the coordinates for. It does not give me the coordinates for all those that it created. This is the area of the polygon. Automatically gives me that. I'm not sure why, but it does. And I have the length of the segment I created too. So I could go ahead and create points at all the rest of these and get those other links and coordinates if I want to. Now remember, if I want to change it, I use my select. And if I can make it bigger, I can rotate it, and so forth. And everything changes dynamically. And this was a regular polygon, so it remains regular. I could have just done a non-regular polygon by creating 3 sides together like that. So that one's called polygon 2. It's a triangle, and there's its area. Here are the segments, the lengths of the segments I used to create it, the coordinates of the points that I used to create it. Notice when I go over something here, it's highlighted. It ends up being highlighted over in both screens as well. So with this, again, you'll just have to play to learn where all the tools are. But these are the tools you might be interested in right now since you're doing transformations at school. So for example, reflection. Now once I choose the transformation if I want, once I go up here, it tells me what I need to do it. So it says select object to reflect and then the line of reflection. So I'm going to create a line of reflection first. So I'm going to say this is my line of reflection. Now I'm going to say, okay, I want to reflect, let's do the triangle over this line. And there it is. Now, if I change that pre-image in any way, the image will change accordingly. Okay? I can't change anything on the image because, as you know, it is a function of that pre-image. I can do it again. Let's see here. Let's now reflect. I'm going to reflect an object about a point this time. So start the object and then the center point. So I'm going to take this polygon and reflect it over the point D, that center point. There you go. And again, I can then change it. and it will all react accordingly. So under here, you've got your reflection about a circle, rotate around a point, translate by a vector, and dilate from a point. So I'm assuming this year you'll be working on reflections about a line, rotating around a point, translating by a vector, and dilating from a point, are the transformations you'll probably focus on this year. You can play with this. For example, you could put an image in there and then take that image and rotate it and create some things. There's all sorts of fun things you can do. So anyway, I hope that gets you started with some fun things to go. Oh, CAS. I don't know if you know what CAS is. CAS stands for Computer Algebra System. It essentially is a tool that can do symbolic manipulation. So for example, factor, and I want it to factor x to the second minus 5x plus 6. It can factor it. Solve x to the second minus 5x plus 6 equals 0. It gives me the solutions. It can do all sorts of things, so it's just fun to play with, and you can see what you can do there. Really great to use for a learning tool, but it takes the right kind of teacher to use it that way, but it's definitely a way you can check your work when you're at home if you're unsure about anything. So, lots of fun here. If you have any questions, let me know. Otherwise, enjoy. Love you. Bye.